So we've been talking about things like units and conversions, or sorry, units, numbers, big and small, and dimensions. Like we can use different units to describe the same thing. And so very often we'll want to convert like one type of unit into another. So in order to do these conversions, first we need a conversion factor, and I wrote some of them down here. I also left our table of scientific prefixes because we can use that as well. So to start out with, like what I mean this, we could write down, let's say 1 centimeter. Remember, centi is 10 to the minus 2. So 1 centimeter is 10 to the minus 2 meters. We can leave it like that, but I'd rather multiply by 100 and say 100 centimeters is 1 meter. And this is a conversion factor. And kind of the trick to using conversion factors is just to treat units like you would treat variables in algebra. You can cross them off, you can divide and cross them off, things like that. We'll see with examples. Let's look at a very simple example. So I wrote down a few conversion factors here. 1 inch is 2.54 centimeters. That's actually a really nice conversion factor to have. I put that in the equation sheet. And it's a good one because this is exactly true. 1 inch is exactly 2.54 centimeters. Now, how is that possible? And the answer is that it's defined that way. We can never measure something exactly, but I remember we defined what a meter was. We give it a definition so that by nature is exact. And so we have a precise definition for a centimeter. That's just 1/100th of a meter. And so we defined an inch in terms of a centimeter. Remember how hard it was to define what a meter is? Well, let's not go through that same process to get something like inches. Let's just define it in terms of something that already exists. Okay. And so that's one reason why that's a good conversion factor to know, because it's exact. But also, this is what connects us between our English system and the metric. So I want to be a little more clear. I say metric. There's actually different metric systems in use. Like I mentioned, our base units are kilogram, meter, and second. Those are the 3 base units that we use in this class. Now, back in the 60s, or maybe even before that, actually I think going much back further before that, there was another kind of metric system that's, this kind of base 10 thing, but it was called the CGS system, which is actually still in use. There are some advantages to this, but this is the centimeter, gram second. So that's what CGS stands for. So again, it's a length, mass, and time, just like length, mass, and time. You're using kilograms and meters. Here are centimeters and grams. Not too much of a difference, but this is an older system. And when it comes to things like electricity and magnetism, this one actually has some advantages. This one is called the SI system. It's also called the MKS, meter, kilogram, second. But SI stands for System International. This is the most widely used kind of basic system in science. So again, different examples of the metric system, just what you want to call your fundamental units. But we pretty much stick with SI. Okay, so this is what connects our English system with our SI, System International. Now, so let's do first we'll do a very simple calculation. Let's say 39 0.5 feet, how many meters is that? So we need to cut. Now, what I like to do, let's draw this as a fraction. So 39.5 feet just over 1. And we want to convert this to meters. And this will involve a couple of steps. But first off, we know 1 foot is 12 inches. So I'm going to write this down. 12 inches and 1 foot on the bottom. Now the question is, can we take our distance and multiply it by something without changing it? Well, 12 inches is 1 foot, and so we're just taking something and dividing it by itself, and so this fraction is equal to 1. So we're not changing anything by multiplying by this conversion factor. And so that's a totally legitimate thing to do. And if we actually multiply this, feet will cancel out and we'll have inches. That'll tell us our distance in inches. But we want meters. So we need another conversion factor. We can say 1 inch is 2.54 centimeters. And again, it's kind of important to get where you put these right. Like I put 2.54 centimeters on top and inches on the bottom, so the inches cancel out. Now, technically, if you did it the other way around, your answer wouldn't be wrong, it just wouldn't be what you're looking for exactly. And it's perfectly valid to multiply it by 1 inch over 2.54 centimeters, but then the inches won't cancel out and you won't get your answer in meters at the end. So what you'd get would still be a correct answer, just kind of not a useful one. And finally, one more conversion factor. Say 1 meter is 100 centimeters. And here's my other cat. This is Rigel. Rigel? Okay, so let's go through and where we treat this like we treat units like we would treat variables. So like one on top, one on bottom, they cancel out, inches cancel, centimeters cancel, and we're left with units. And then we just have to multiply the numbers. So let's do that. 39.5 times 12 times 2.54, and this would be around 12 meters. Okay, so that's a kind of a simple conversion. Maybe I could have done, I guess the simplest one of all would just involve multiplying by a single conversion factor, but this just took 3. I mean, the same kind of concept. So I could have maybe started with one that was a little easier. Yeah, 39.5 feet is about 12 meters. Like 12.04, but 3 significant figures, so 12.0. Trying to set a good example. Okay. Now that was kind of a straightforward one. I'm going to move this over. 100 centimeters is 1 meter. I'm going to do another example of a conversion. I think we'll do 2 more. But one just because it's very common, and we can also illustrate another concept that could help us out. But let's say you're driving and you suddenly, you go into Canada and you look at the speed limit signs and they're in kilometers per hour and you have no idea what to do. So let's say, actually I don't know what they use. Let's say 100 kilometers an hour. Or let's say 90. Let's just say you see a sign, the speed limit is 90 kilometers per hour. Okay. And you have no idea what that is. or at least intuitively, you know miles per hour. Now, modern cars have both on their speedometer, so you could just keep driving and look at the speedometer. But pretty sure older American cars won't even have a kilometer thing. So let's convert this and try to make sense more intuitively. I'm going to leave a little room. 90 kilometers an hour. And we want to convert this to something we're more familiar with, which would be miles per hour. And, yeah, actually I think we'll do another example after this that I wasn't intending, but let's just do this first. So, 1 kilometer is equal to 10 to the third meters, or 1,000 meters. So let's start with that. We can say 1,000 meters is equal to 1 kilometer. So now we have meters per hour. But what we want is miles per hour. So we're going to have to convert meters into miles. And we're just going to go kind of in a very straightforward way and do that. So let's use this conversion factor here. We can say 100 centimeters is equal to 1 meter. So that cancels out. And then we want to get to miles, so we have to switch over to the English system. 1 inch is 2.54 centimeters. And there are 12 inches. And 1 foot. And 1 mile. I didn't write this one down here, probably should have. But 1 mile is 1,000 200. Oh, sorry. 1 mile, 5,280 feet. And so if we just cross off, centimeters cancel, inches cancel, feet cancel, and the only units we're left with on top, mile, on bottom, we have hours. And so we can now just plug in the numbers. So we have 90 times 1,000 times 100 divided by 2.54 and 12 and then 5280. Oh, this actually worked out fairly well because what we end up with is 55.9 miles per hour. Which we use 55 in some places. So yeah, they probably have 90 kilometers an hour, speed limits in Canada. I wouldn't be surprised at all. Okay, so yeah, again, this whole idea of converting systems, if you have the conversion factors, it's not easy, and in a sense, if you understand what you're doing, it's actually hard to get it wrong. But if you're just learning it, this is one of those things that students actually do struggle with. So I'm not going to say, this is easy if you don't get it, something is wrong. That's not the case at all. This is a subject that does confuse students at first. And this is kind of a difficult topic to teach because it really depends a lot on the class. It seems like everyone that I teach has been exposed to this before. And so it's hard to know, can't remember to jump down. It's hard to know, I don't want to spend a lot of time going over this stuff if everyone always knows it. But then there's always that one student that doesn't, and then we don't want to gloss over this without covering it. And so I'm going to wait till, we actually talk in person and get an idea of where the class is before going too deeply into this. So we'll just do a few examples and then move on, but then we'll talk about it, during the online lectures. Okay, But I mentioned that, as you can see, it's kind of a straightforward process. I want to mention, if you understand how to do this, you shouldn't get it wrong because, you just cancel it out and we can see the units work out this way. And so, if you understand the process, you should enjoy seeing questions like this on the exam because you should get them right if you've done your homework and know how to do it. But in this case, there was a fair amount of work involved here. And we can kind of simplify things. Let's say we have, I'm going to write down, let's convert 1 mile into meters. So let's just do this off to the side. So we'll start with 1 mile. And basically we're going to do a lot of these conversion factors. 1 mile, that's 5,280 feet. And then 12 inches per foot. 2.54 centimeters in 1 inch. And then 1 meter is 100 centimeters. So let's do this calculation and see what we get. 5,280 times 12 times 2.54. And then divided by 100. And we get 1,609 meters. And this kind of calculation going between miles and meters, this comes up fairly often because, we have to use both the English and the metric system. So we can do this calculation once and write this down somewhere, like on your equation sheet, which this should be on there. 1 mile is 1,609 meters. And if we do that just once, now we can come back to this problem and make our lives much easier. We have kilometers per hour. We can erase all of this. And then we did 1,000 meters per kilometer, and then say 1 mile is 1,609 meters. So, kilometers cancel, meters cancel, and now we have miles per hour. So again, you don't always have to have these long chains of conversion factors. Sometimes, a lot of them, it's already been done for you. Like 1 mile is 1,609 meters. That one's easy to look up. And so that greatly shortens the problem. But there's one more. This is like the biggest issue with conversion factors. I've noticed students make this mistake. And it's kind of interesting because I tell students all the time, never make this mistake, but still there's always confusion about this. Let's say that we have a rectangle. Let's say this is 12 inches and this is 30 inches. And I want to know the area of this rectangle in square centimeters. So first let's calculate the area. 30 times 12, 12 times 3 is 36. So this would be 360 inches squared. So we're not just doing 30 times 12, we're doing 30 inches times 12 inches. So that's 360 inches squared. But I asked for the area in square centimeters. And so we can use this conversion factor. 1 inch is 2.54 centimeters. And this is the answer I see all the time. If I were to ask this on a quiz or a test, I would expect to see someone do this no matter how many times I tell you not to do this. But an answer I would expect to see would be 914.4. I'll just say 914 centimeters squared. This is wrong. And what it is just 360 times 2.54. But again, this is a very common mistake. And it kind of looks right because you're converting inches to centimeters. But again, what I encourage everyone to do is never ignore units in calculations. So if we do this calculation, if we look at the units, what we have are inches squared. You can write it like this: inches times centimeters divided by inches. So the units we get, we have an area of 914 inches times centimeters. Now that is correct, it's just not what I was asking for. I mean, if you wrote this down, I mean, that is the area, 914 inches times centimeters, but the question was asking centimeters squared. And so what we'd have to do is apply this conversion factor twice. So again, now we'd have an extra centimeter here and an extra inch on the bottom, and those inches would cancel, and our units would be centimeters squared. So let's do that. So the correct answer is 2,410 centimeters squared. Well, this is also a correct answer, but not the one I was looking for. And sometimes you will actually see mixed units like this. An example, water levels. Like, I think they try to use that to measure like how much water is in a certain like plot of land. They use like an acre foot as a unit. That'd be like 1 acre of land, 1 foot deep. And so it kind of makes sense because you're measuring like a large area in one direction or like in one plane, but then depth, you're only going a shallow distance. So it makes sense to use the area and the depth with different units. So something like this could actually make sense, and it's technically correct, but we want centimeters squared, so that would be what you should write down. And a more compact way to do this, you could write the conversion factor twice, or you could just square the conversion factor. Now, another place this comes up is when it comes to volume, where you measure volume in like cubic meters, cubic inches, cubic centimeters. Like a volume, if you have a rectangular object, it'd be like length times width times height, and each of those has like, say, inches to it. So you'd have an inch times an inch times an inch, that would be cubic inches. And again, if you want to convert that from cubic inches to cubic centimeters, you'd have to cube the conversion factor. So again, just always remember, or you don't even really need to remember if you get in the right habit of just treating units, just writing those down as you're doing your calculation, and you'll never go wrong that way. So that's, but still, this issue just keeps coming up, where someone always forgets to square or cube the conversion factor. Okay, so I think that'll be it for conversions, and then when we get to the online lectures, we'll try to see if we need to cover this in more detail. Because I think chemistry, most people have had that, and you do cover this. So that'll actually be it for chapter 1, so we'll stop it here.